Good morning, everyone. Welcome to the One Concept Per Day portal. And this is the fourth question that we are doing currently in basic kinematics. Okay. The first three questions were focused more on finding out what are the kinematic parameters like distance, displacement, finding out the velocity, or maybe using your VT graph and so on. So this question is once again based on calculating the basic kinematic parameters. Let us do this. A little bit variant, a different question as compared to the previous ones. Okay, the question reads like this. The shutter camera of a speed of a camera is the time that the film is exposed to light. Okay, so in the old cameras we had something like a shutter speed. So it opens and it closes. And then in order to determine the shutter speed of a camera, a metal ball is placed at rest at the zero mark of a vertical scale. So you keep it over here. The ball is released. So the moment it releases, what happens? It falls down like this. The shutter of a camera is opened as the ball falls. Now the ball starts falling over here. The moment it reaches somewhere over here, you open this. Okay. And then a photograph of the ball shows that the shutter opened as the ball reached 196 centimeter. Okay, the moment you open it over here, so it opened, it was able to capture the photo of the ball which was at 196 centimeter. And when you click it, when you open and when you close it, what happens is, okay, it closed at 208 centimeter when the ball passed away here. Air resistance is negligible and the acceleration of free fall is given over here. Calculate the time taken for the ball to fall from rest to the 196 centimeter mark. Okay, you need to find out what is the time taken by the ball to start from here and to reach this point. This is the time which has been asked. How do you do? Simple question. So the initial velocity of the ball is 0 because you say it is a dropped, right? You are not thrown, you just dropped over here. And then when it reaches this point, it is second time t. So I can use my equation s equal to ut plus half a t square. And s is nothing but 196 centimeter. If I convert it into meters, I will get this as a 1.96. But most of the time, students have a question asking that should it be plus 1.96 or minus 1.96. Sometimes most of you take this as plus 1.96. I'll tell you, I'm not going to take this plus 1.96. The reason is because it all comes from your sign notation. So let me assume that this is my x-axis. This is my positive y-axis. And whatever I measure downward is my negative y-axis. So therefore, definitely this height, I'm going to take it as minus 1.96. I'll write this as minus 1.96 is equal to ut. What is the value of u here? U is 0 plus half into value of a is minus g multiplied by t square. I take g equal to 9.8. So that now I can now cross multiply this, get the value of t over here. So now I have t square is equal to minus 1.96 multiplied by 2 divided by minus 9.8, right? So this minus and minus goes away. So therefore I get 1.96 into 2 divided by 9.8. Let us calculate that value. So when I do this, let me take this here. 1.96 multiplied by 2 divided by 9.8. I get this as 0.4. So t square equal to 0.4. T is equal to square root of 0.4. which should now be equal to, take the square root of this, which should be 0.632. 0.632 unit second. So the time taken, let me type that as T1 over here. Time taken by the ball to start from here and to reach here is going to be 0.632 seconds. So I will write down here 0.632 seconds. Determine the time taken for which the shutter was open, that is the time for the ball to fall from 196 to 208 centimeter mark. What is the time taken to start from here and to reach here? This I want t. So this t, what I can do is, see, calculating from here to here is quite easier. I use an equation of motion. In a similar way, I can also calculate from here to here, right? I can call this t2. And then what I can do is I can subtract from t2 minus t1. T2 minus T1 is equal to T, because there is no straightforward method to calculate this, or maybe it might be a little bit complex to do this. So this would be an easier method to find out the time taken. Okay, I'll use this method. So towards it, what I will do is I need to do a calculation for T2. The same type of calculation what I have done, I need to do it for T2 also. So how do I do? What did I do here? T2 square. I'll write instead of T1 square, I'll write T2 square is equal to, what is this 1.96? This height. Instead of this 1.96, I am going to replace this by this height over here, right? Because I am going to calculate for T2. So this height, what is this height? 2.08 meters. 2.08 meters. Multiply this by 2. Divided by 9.8. Once again, 9.8. Okay. So therefore, now let us calculate this, which should now be equal to 2.08 multiplied by 2 divided by 9.8, which should now be 0.4244. I have got this one here. Since I need the value of T2 here, T2 will now be equal to square root of that value. What is the square root of that value? When I do this, I get this as 0.651. 0.651 seconds. Right? So therefore, now I have got, let me write down. So this was your T1 and this was your T2, which is 0.651 second. What is it I need? I need delta T. Delta T should be T2 minus T1, which should be 0.651 minus 0.632, which should now be equal to 0.651 minus 0.632 will be 0.019 seconds. 0.019 seconds. This is what is the time taken by the tennis ball travel this distance over here. Okay, next. Explain why a more accurate value for the shutter speed can be obtained if the ball is allowed to fall a greater distance before the shutter is opened. Okay, so will I be happy only with this one, or can I change my experiment? Okay, so how do I change my experiment? So what I need to do is, so instead of having this height, if I have a larger height, okay, then what is the outcome of this one? If I have a larger height, instead of saying 196 and 208, let us say I have a larger height. I throw it from here. Okay, let's say this is 5 meters over here. Now, when I put the camera over here, the shutter will open here. Let us say something like around 4.1 meters it opens. The total length is 5 meters. So let us say 4.1 meter over here. The next time when it opens, this distance would have been much more larger over here. This could be 5 meter over here. So as a result of this, the distance traveled is larger here, right? The distance traveled here is larger. When you say distance is larger over here, then what can happen? The fractional error, okay, of delta x by x will be lower, which means the accuracy will be higher. See, what is it asking here? Explain why a more accurate value for the shutter speed can be obtained. So how is it related to the shutter speed? If you ask me that question, then you can answer it like this. So so what is this? How is this delta x related to this? Now delta x, let me go back here. Now you see here, this delta x is related to time using this method, right? So this is your delta x. This is your delta x here. This is your delta x. What did we do here for delta x? So we took delta x is equal to, first let me write it down here. Delta x is equal to x2 minus x1. What was x2? x2 was half gt2 square. What is x1? Half gt1 square, right? So which should now be equal to half g into t2 square minus t1 square. Okay, so therefore now this delta x depends on this. If I divide this by delta x by x, then what do I get? I get this as divide by this like this over here. So you get this as x is equal to, I can write like this over here. So as a result of this, you see, this delta x by x becomes lesser because this value of x is larger over here, right? Because if the distance is larger, it will travel with a larger velocity, and this will also be larger over here. And as a result of it, delta x will be larger. Sorry, x will be larger. Okay, and thus you can find out this fractional error will be lower over here. So with this, we come to an end to this particular problem. And if you really like these videos, do like, share, subscribe to my channel for more updates. So what is that we will be doing it in further can also be notified. Thank you.